Okay, hi guys. So we'll continue on seeing the n factor for the calculation of oxidants and reductants. So let's get started. So we were seeing in the previous lecture some of the examples, so we'll be continuing on seeing that. What if we have one H plus which accept one electron to form half moles of hydrogen gas? So in this number of rather the molar mass of H plus would be again 1, number of electrons gained would be 1, n factor would be 1. Next is we have Cl2, okay, plus 2 moles of which accepts 2 moles of electrons to form 2Cl minus. So n factor here would be 2. How? So this is actually n factor, but we actually the n factor of this would obviously be 1, and if we talk about the equivalent weight of H plus, that would also be. So this is not molar mass, I beg your pardon. This is when we are talking about equivalent weight of H plus, then I was talking, then you should see into the consideration number of rather molar mass of H plus and then n factor. So this would give you 1. N factor is, you can directly write it 1 because number of moles of electron accepted by 1 mole of H plus is only 1, hence n factor is directly 1. Similarly here you can directly write that n factor for this is 2. Why? Because the number of moles of electron accepted by 1 mole of Cl2 is 2, so 2 upon 1 is 2, and equivalent weight of Cl2 would be molar mass of Cl2, which would be 71, and n factor of Cl2 which would be 2, hence the equivalent weight would be 35.5. Okay, so I suppose that in the previous lecture also, using this example, which was the last example, I might have told by mistake that equivalent weight would be instead of calculating n factor, I might have told orally that the formula of equivalent weight, in which I did molar mass of 2 upon 2, so that was wrong. N factor of this can be directly written as 1. Why? Because the moles of electrons accepted by 2H plus is 2, hence n factor would be 2. Why? Because n factor is calculated in H plus on the lines that how many moles of electrons it is accepting, which is 2, and how many moles of H plus is consuming in the reaction. So n factor would be 1, and equivalent weight would be molar mass of 2H plus divided by so molar mass of H plus would be 1 and n factor is 1, so molar equivalent weight would be 1. I might have orally told the formula of equivalent weight while calculating n factor, so I am just correcting that thing here. Okay, n factor is calculated with, in case of H plus, moles of electrons accepted or released, so in this case moles of electrons accepted divided by moles of H plus consumed. Okay, and equivalent weight is molar mass upon n factor. So keep these two things very much clear in mind. Okay, so next is we have 2 moles of OH minus forming H2O plus half moles of oxygen plus 2 electrons. So here n factor would be number of moles of electrons accepted or released, which would be 2 here, and number of moles of OH minus consumed, which would again be 2, so the n factor is 1, and equivalent weight you can calculate with the same, means this formula. Okay, now we have 2 moles of H2O plus Cl2 plus 4 electrons combining to form 4 moles of OH minus. So let's see the n factor, this is O2, not Cl2, this is O2. So this n factor would be what are the number of moles of electrons accepted by O2? That would be 4, and moles of oxygen consumed would be 1. So n factor would be 4, and equivalent weight of oxygen would be molar mass of O2 upon n factor, which is 4. Molar mass of O2 would be 32 by 4, so equivalent weight would be 8 grams. Let's see another example wherein we have zinc metal converting into Zn+2 and 2+, maybe in aqueous phase. So n factor would be number of moles of electrons released would be 2, number of moles of zinc consumed would be 1, n factor would be 2. You can calculate the equivalent weight from n factor. Then we have copper in +2 state, accepting electron, converting into copper. So n factor would be number of moles of electron released or consumed 2, number of moles of Cu+2 consumed 1, n factor would be 2. Okay. Next, let's talk about KMnO4. KMnO4 in dilute solution, it is pink in color. Okay, and it dissociates into ions which are K plus and MnO4 minus. Okay, here the equivalent weight of KMnO4 would be molar mass of KMnO4 upon five, or equivalent weight of KMnO4 can be molar mass of KMnO4 upon 3, or equivalent weight of KMnO4 can be equal to molar mass of KMnO4 upon 1. So we can see 3 different n factors of KMnO4 present depending on the type of reaction and the nature of reaction. So what happens here is Mn is in +7 state in MnO4 minus. So in acidic medium, what will happen is n factor would be 5, and this will actually reduce Mn in +7 state to Mn in +2 state, which is colorless. Okay, next, what happens in neutral medium? So in neutral medium, n factor is of KMnO4 is 3, and this Mn +7 it get reduced to Mn +4. Okay, and in then highly basic medium, what will happen? This is MEDIU1. N factor of KMnO4 would be 1. Okay, and this reduces Mn in +7 state to Mn in +6 state, which is green in color. Okay, next let us see one more oxidizing agent, which is K2Cr2O7. So here this will dissociate into 2K plus Cr2O7 2 minus. So Cr2O7 in Cr2O7 2 minus, Cr is in +6 oxidation state or is in +6 state and gets converted into Cr +3. So number of moles of electrons accepted by Cr would be so this is simply you can multiply it with 2 just to balance it. So balancing may or may not be required. So from +3 state, it +6 state, it went to +3 state. So 3 electrons accepted here, and how many atoms of Cr were present? So it were 2. So total moles of electrons accepted by 1 mole of Cr would be 6. Okay, so n factor would be 3 into 2. Okay, so let me write it down again. So let me again write it down why the n factor is 6 here for the compound Cr2O7 2 minus. So if you look at it, one Cr atom is going from Cr plus 6 state to Cr plus 3 state, hence total number of electron gained by one Cr would be 3 electrons, and here we have in Cr2O7 there are 2 you can say moles or atoms of Cr, hence total moles of electrons gained by 2 moles of Cr plus 6 2 plus 3 would be 3 into 2 or 6 electrons. Okay, so we can say that the n factor of Cr2O7 minus 2 would be 6. Okay, so with this we come to the end of this lecture. In the next lecture we will be seeing the calculation of n factor for more compounds, and we'll be seeing some theory as well. Till then, good luck and goodbye.